Today we'll be looking at word problems that are represented by systems of inequalities. So taking a look at number 1, we just want to explain why only certain parts of the coordinate plane are given or used when we're doing a system of inequalities with a realistic problem. So for number 1, we have the local theater in Jamie's hometown has a maximum capacity of 160 people. Jamie shared with Venus the following graph and said that the shaded region represented all the possible combinations of adult and child tickets that could be sold for one show. Explain why parts of the shaded area would not be solutions and which part contain all realistic solutions. So the parts of this graph that would not be realistic are the parts that would wind up giving you a negative number of adults or children. So if you're in quadrant 2, you would have a negative number of children attending this event. If you're in quadrant 3, we would have a negative number of adults and children. If you're in quadrant 4, we'd have a negative number of adults. So the only part of this graph that represents realistic solutions is the part graphed in quadrant 1. So only quadrant 1 represents realistic solutions, as you would not have a negative number of adults or children attend the event. So most of the time when you're asked to graph an inequality for a real problem or a real world problem, you're only given the first quadrant. All right, so taking a look at number 1, we have Sarah is selling bracelets and earrings to make money for summer vacation. The bracelets cost $2 each, and if you look at the graph, bracelets are going to be our Y, and earrings cost $3 each. Earrings are going to be our X. Sarah already has orders for a minimum of 50 bracelets. Bracelets we know is already our Y, so Y is going to be minimum, which means greater than or equal to 50, and wants to make at least $500. So we put them together. 3x plus 2y is greater than or equal to 500. Find the solution set that contains all possible ways Sarah can make $500 selling earrings and bracelets. Identify and check one solution. So we can start with the first equation, y is greater than or equal to 50, by graphing a horizontal line at 50 and shading above. And then for the second equation, we have to do some rewriting. So we subtract 3x. 2y is greater than or equal to negative 3x plus 500. Divide by 2. And y is greater than or equal to negative 3 halves x plus 250. So in this case, it would be easier to use our graphing calculator to graph that equation. So we go over to our y equals. We type in negative 3 divided by 2, x plus 250. And I just made a very common mistake. I put a minus for a negative, so I'm going to change that to a negative. And I forgot my plus 250. So I'm going to go to second and insert and add my plus sign instead of deleting everything. And now I can pull up my table. And you can see I already have this set up as in 50s, which will make my life easier since my bottom x-axis is in 50s. So we can go ahead and just use those intervals of 50. And in case you don't remember how to do that, you would go to second table set and start at 0, change by 50. So I'm going to graph 0 to 50, then 50 and 175, which would be in between 150 and 200, then 100 and 100. I put my 50 in the wrong spot. Let me move that over. And then 150, and 25. And that's going to be a dotted line. Nope, a solid line as well, because it is equal. And we want to shade again above because it's greater than or equal to. So all these points above the green and above the blue are part of our solution set. So one point that we could check if we're making exactly that $500 would be 100 earrings and 100 bracelets. And if I plug that in, 100 bracelets is definitely greater than 50. So that checks out. And on the bottom, if I do 3 times 100, I get 300. Plus 2 times 100, I get 200. It's greater than or equal to 500. And 500 is equal to 500. So that one also checks out. So we could say 100 earrings and 100 bracelets as one of the possible solutions. We could say 100 earrings and 150 bracelets because that would also fall in the solution set, and check that instead. It's really up to you. Just make sure that if you're picking a point, it is in the shaded area or on a solid line, not on a dotted line, because that would not be part of the solution set. All right, let's take a look at number 3. Okay, for number 3, we have Jason is buying wings and hot dogs for a party. So if you're looking at the graph, we know that wings are going to be our X and hot dogs are going to be our Y. One package of wings costs $7 and hot dogs cost $4 per pound. Jason knows that he needs at least 5 pounds of hot dogs. So hot dogs are our Y, so we know that has to be at least or greater than or equal to 5. So we can start by drawing that line. And then we know that he cannot spend more than $40. So our second equation, we have to apply our prices. So that would be $7 per wing plus $4 per hot dog pound is no more than 40, so less than 40. Rewriting our equation by subtracting 7x, we get 4y is greater than 40 minus 7x. Dividing by 4, we get y is less than 10 minus 7/4 x. So in this case, I don't really need a calculator because my axes are even. I did forget to shade in the last one, so I'm going to go back and shade above the 5. Now I'm going to go back and graph the second equation. So starting at 40, or 10 rather, we're going to go down 7 and over 4. So down 7 brings me to 3 and over 4. And those are the only 2 points I can draw. And I need a dotted line between them. And I need to make sure that I shade below and label that line with the original equation. 7x plus 4y is less than 40. All right, so my solution set is just this very small area here, not including my dotted line. Everything below the dotted line would be part of the solution set. So it does say to find the solution set that contains all possible ways. We did that. And now we have to identify and check one possible solution. So we could get, looks like 2 packages of wings and 6 pounds of hot dogs to work. So let's check that out. If I put in 6 here, 6 is greater than or equal to 5, so that works. And if I do 7 times 2 plus 4 times 6, I should be less than 40. Let's just prove it. So that's 14 plus 24 should be less than 40. And $38 is less than 40. So we could do 2 packages of wings and 6 pounds of hot dogs as our answer. All right, let's take a look at one more problem together. For number 3, we have in Mrs. Dwyer's class, the number of boys is more than twice the number of girls. There are at least 2 girls and there are no more than 12 boys. Write 3 inequalities to represent the number of boys and girls in Mrs. Dwyer's class, letting X be the number of girls and Y be the number of boys. Graph the inequalities on the coordinate plane and state 2 possible solutions for the number of boys and girls in her class. All right, so we have 3 equations. First, we know again that girls are X and boys are Y. So we have the number of boys, which is Y, is more than twice the number of girls, 2X. So there's one equation. There are at least 2 girls in her class. So girls are X, at least 2 girls, so at greater than or equal to 2. And there are no more than 12 boys. So boys are Y, and there's no more than 12 of them. So that's 12 or less than or equal to 12. So there's our 3 equations, and we can go back and start graphing them. So firstly, we have Y is greater than 2X. So we start at 0. We go up 2 over 1. And we need a dotted line there because it's just more than, not more than or equal to. Arrow on the end, label it with the equation. And it's greater than, so we're going to shade above. Okay, then we have X has to be greater than or equal to 2. So we haven't done any of these X equal ones, but for X equals, we find the X where X is 2, and we're going to draw a vertical line. And we're going to shade to the greater side of the graph. It's actually much nicer to see these when they're done in color. So if you have a highlighter or colored pencil that you would like to graph with instead, be my guest. All right, and then the last one, Y is less than or equal to 12. So Y is 12, and we need a solid line again. And we're going to shade below. So that means the triangle that's created by the blue line and the red lines there are our solution set. So this part here contains all of the solutions, but not on the red line. It could be on, oh, not even that blue line there. It has to be below that green line. So this part here would be all of the solutions. Okay, so now remember, if it's on the green line or on the blue line, yes, it is a solution. But if it's on that red dotted line, it's not considered a solution because it has to be greater than. All right, so now let's state 2 solutions for the number of boys and girls in Miss Dwyer's class. So she could have, let's see, 4 girls and 12 boys. It's okay that we're on the green line for 12 because it was less than or equal to that. We could have 3 girls and 10 boys. That's also in the solution. Okay, so again, very important to take your time doing these problems. Be really careful with your dotted lines and your solid lines and labeling so that you're not losing silly points, especially when it comes to the regions on things like that. All right, so you guys are now on your own. Answer your exit tickets and then start your homework.